All right, Kathi, thank you so much for coming to present to us, and take it away.
Okay, short translation of the first slide. So this is still a Dutch presentation I did a few weeks ago, and it is observations and measurements and samples. The monsters is the Dutch word for samples, and this is just too nice to have. So what is this all about? Let me see if I can remember my own presentation. So I mean, the background, the example is air quality. That's the easiest thing I had lying around. You have a map, and you somehow want to have some places, some spatially located things. You want to measure stuff on that. So we've got here various air quality pollutants, and then you want to see what measurements came out. This is what we're doing it all for. And what are we doing? Okay, we've got the observations, measurements, and sample standard. That is an OGC ISO standard. Under ISO, it runs as 19156. Under OGC, it was observations and measurements, where we are currently in the final steps of updating. The new version will be out sometime during the course of this year. And there we have very purposely changed the name a little bit. It is now observations, measurements, and samples, because the original version, which was the ISO from 2011, also covered samples. It was all there. It was the second part of the standard. And we, as the ones really writing it and responsible for it, kept forgetting about it. And so we can't forget. We've now added it to the standard at the risk of breaking the O&M acronym we've all gotten used to. We are now trying to adjust to call it OMS, so nobody remembers these, nobody forgets the samples. Nobody remembering the samples was our problem. Okay, I'm getting tired here. It's part of the general ISO 191XX suite of spatial standards. So basically all of the spatial stuff over ISO coming from OGC is in here. They're all fairly aligned with each other. In OGC, it's provided also as abstract topic 20. So it's one of the really core standards within OGC trying to sort spatial data. And it's utilized, okay, this is again a bit European-centric. We use it strongly within the European Inspire Directive, where all European member states have to get all environmentally relevant spatial data online. So there we've got a fairly large audience, but it's utilized in smart cities, digital twins, whatever the metaverse is morphing to be. So it's pretty omnipresent, both in environmental things, but also way beyond. I mean, the call before was with a sensor things expert, and he was showing me how the city of Hamburg has their traffic lights on sensor things. And we were watching in real time how the various streets would go red and green. So that cool thing can make us happy. Okay, what is this standard? I did a very trivial example because it's tricky enough anyway, and I think this is the easiest way to get the point across. The classic way of providing attributes to something. I mean, you've got something, in this case, we've got our smiley face sticker, and we've got some facts about it we want to add. Simplest data modeling is saying, I make my class smiley face, I give it the attributes color and expression. They have the values yellow and happy, and everything is simple. This is how various database systems or data systems generally have been designed over the decades. It works for each example. It's not very generic. And it has various issues. I mean, it's fine if I can just say color is yellow, but what if I want to provide some information on how did I determine this? Results often depend on the methodology, what the possible result value domain can be. If I only have red, blue, and green as colors, I can't provide yellow as a result. So I'd like to provide something on the procedure I used, what swatch comparison. This could include all the different swatches I was using, but right now it's floating into space. So in order to attach this to the concept that the color is yellow, we need to somehow put something here in the middle, which we can attach it to. So we can define this node in the middle. This is our observation. From this, we can say, okay, we've got this procedure swatch comparison, but if we do this, we lost the fact that we're dealing with color. So the first thing we have to do to add the observation correctly, we also need to say we have an observed property, color. So now we know that this little node in the middle is providing information on color with the procedure swatch comparison. we do need to describe what is the arrow going off to the right, so that we actually then give the name result. And we also, since we're now focused from this middle point, we need some proper connection here. So the way we do this in O&M is that we call it the thing we are observing the feature of interest, and the observation ties all of this together. A short side note, talking through this recently with people, they pointed out they also want it the other way. So, I mean, it's very common in various systems that this feature of interest has an inverse relation, which can be either the specialized the color, or it can just be related observation, go through the observable properties. So this is the core of O&M, the way it's been standing for 10 or actually 20 years. I mentioned we've been doing an update, and part of the update has been adding some additional concepts which we kept needing. So one of the concepts we kept running into was the observer. This was also partially done to disaggregate. We'd always had the question on the procedure. Is this the abstract procedure, or is this the device doing it? Is it the class, or is it the instance? And every system did this differently. And then we realized, okay, we need a place for both. We need something to describe how was this process done, and we need a way to describe who done the process. And we'd initially called it actually sensor. And then we realized, wait, we've often run into the problem that when we have human beings going out, looking at something, comparing the swatches, we have to explain to them that you are actually a sensor in this context. And we decided it's easier to explain to the sensor that it's an observer. So we abstracted the association of what is actually doing the observation, called it observer. This can be specialized down to sensor, but this can also be a grad student you chase out into the field and say, go fetch and figure out. A further bit we added was what we call the host. And this was also a bit based on the work in Inspire, and also the general realization that it's not always in soil, but in most cases where you're measuring something, there is some wider setup around it. There's usually some station, or I mean, even if you have some lightweight sensors, you tend to mount them on something. And with soil, you often have sites which you revisit. So some concept, where is the wider thing which this measurement observation thingy is related to? So that is now the host association. And this way you can now say that the smiley face has the color yellow. So we've got the color here, we've got the yellow here, we've got how it was done, we know who done it, and we know it was done in this location. And we can do the same thing at the bottom for the expression. So that's again the same pattern. The nice thing with O&M is that you can reuse the same observation for any type of property you are providing information on. You just need further observable properties. That's why I mentioned a bit earlier, I'm not sure if we need the full semantics of soil, or do we just need what are the properties you're currently using, and what procedures do you use for this? What devices do you use? I think if you've got that nailed, you're already really far. But end of rant. Some further details on the observation. I'm going to take away the facial expression, the bottom one, and make a bit more room so we can play here, because we've added some further bits. So if I move the host over here, what we've added is you've got some host, some facility, you've got some device. They're usually somehow related with a date, or with some, when was this device deployed at that place? And for that, we've added the further type deployment, where you can say, this sensor was mounted on this facility, this grad student was sent out on this survey campaign. You can provide the dates when this was done, and you can provide additional contextual information. I don't know why was it done in the context of, I don't know what. So all of these sort of pinkish bits are the ones we've been adding there in the version, which will be available as of sometime during this fall. Okay, where do I continue my talk? I reset this, then I add some further bit, because we do add all sorts of information into the central observation. The first bit are times. We have 3 different times, which they're not always all necessary, but with them we basically get through. Phenomenon time is when did the thing we are observing actually happen. Result time is when was the result available? Sometimes it takes quite a while until the analysis is done, so it's good to differentiate. I took the sample and I sent it in for analysis in early May, but I didn't get the result until September. And the third time we have is the valid time. It's not used that often in observations. It's what time span is this value valid for? And in observations, you can use it to say, okay, we say this value is good for today. Where this becomes really valuable is when you provide modeling data. This is one of the things many people aren't aware of, but you can use O&M not just for things you have measured, but also for things you have modeled. The structure works nicely for both things, and there you need the valid time. So you can say, okay, I have done this forecast, and I say tomorrow it will be 20 degrees, valid tomorrow. So those are the 3 times we have.
Can I make a comment on this, which
Please
is
do.
soil appears as the feature of interest on that left side. It's a very simple thing. You've got a lot of structures on the right.
Hmm?
Now, there is a lot of structures on the left potentially, so that you would be doing multiple observations over time because soil dynamics changes and you want to capture what happens in different times. But it is valuable to have the model developed over here on the left side about soil dynamics.
Yeah, definitely. And that's one of the many models you need. You need not even the dynamics. What are the pieces you are looking at? This is nothing about a process. This is some piece of soil you are providing a measurement on.
Yes, I mentioned dynamics because you have the time, which is the thing you were talking about here. But you need all the elements, the relationships, some of which are sensitive over time. Time sequence.
But you're not talking to the various domain bits, which would be with the smiley faces.
Yes.
Okay, and I mean that is not part of the model we are currently dealing with.
Exactly, I understand, but we're sort of connecting. We would connect SOSA with the models on the left side.
Exactly. And then you would probably also connect some of the further models you have for things like the observed properties and procedures. So, I mean, your models click in both left and right. Does that answer your question?
It certainly does. I hope it makes sense to people. I see Kathi seems to have, well, the other Kathi seems to have a frown, so I'm not sure.
Well, so I also made a note to talk about time and space time in here. That seems I can see the use cases for why it might be associated with the observer, but I do think of these features of interest as being associated with some type of space-time reference. So do you have them in both the feature of interest and the observer?
The observer doesn't have time at all, right? That was a confusion apparently.
Okay.
The time I had here, this is a further class. That's the deployment.
Okay.
And that is used to describe when this observer was deployed to this host.
Okay.
And the assumption is the measurement was within the time the observer was deployed here.
Mm-hmm.
But this has nothing to do with the further times I was talking about.
Okay.
And so, I mean, it's really just, so this one is really just when was the observer in this context?
Okay.
This set of times, these now go into the observation itself. That's where I say, okay, this observation that this smiley face is yellow was done on April 7th.
Mm-hmm.
And that would be the phenomenon time. I shortened it here because otherwise it gets too big. But so, I mean, here we've got a one-off measurement. What we can also do is, I mean, things change over time. And how do we do this? Now we've got a green face and we've got the measurement over 2 days. And we can also do that. So does this start to answer your time things?
So I guess thinking about this as a tuple, the feature of interest would be associated with one of those times that would be associated with a result, or the time period would be associated with both results?
This can be modeled either way. And we have some purists who say, no, there is only one result per observation. And then we've got people dealing with high frequency results who say, no way, I get a value in every second. That don't work. So
Is this an example? We're measuring soil, which is the green face versus the yellow face, and the acidity, it changes between April 6th and April 7th for some reason,
exactly.
right?
So that's showing how you can measure that the world around you is changing. And I mean, one of the things I've been doing a lot of work with over the years was air quality. There you've got a different value every few minutes. That I would also model as one observation and then provide a time series as a result with the hourly values.
Yeah.
An example
so
could
the
be soil
result-
moisture, for instance, or something like a soil moisture sensor would provide a new measurement almost every hour or every day, and that then would be listed on different dates or different hours. That can all be specified, I think.
Right.
Exactly.
And the model is general enough to allow these essentially time series on a regular basis to be there, but also if you have extraordinary events, you might fly over and observe something you don't normally do. So you might have done it in November, and the only other time you do it is in April. That's not a set series, but it's important because something is happening. It's important that you want to observe with a different type of sensor.
And I mean, that could be then two different devices. In OMS, in the update, we've now also added an observation collection. And we've been having some really fun discussions. When do you have just one value per observation and pull them into a collection? So, I mean, that is as you like it. You can do that in various nuances. If you're doing something like that, where you are resampling the same place, but it's a different device each time, then you could model that as a collection of observations and each individual one just as an observation. Okay, let me go on, because I do actually also have a running example of a lot of this. A few more bits that are coming. Feature of interest. Okay, this is also getting a bit towards the sampling. So here I just have generic feature of interest. That's the way it was in the old version of the standard. One of the things we've updated, influenced by the work in SOSA SSN, is they've split it into the proximate feature of interest and the ultimate feature of interest. The FOI is feature of interest, otherwise it again gets too long. What is the difference between these two? Often you have in the real world something and you can't measure the whole thing. You've got a cliff face in front of you. You want to know what type of rock it is. So you chip off a sample and you send that to the lab for analysis. Then you can say the proximate feature of interest. What I'm really analyzing is the sample I've taken. The ultimate feature of interest is what this is the placeholder for. So now you can really reference both. And let me show how that works also together with sampling. So we can say this at the bottom now is our population of smiley faces. Or they're not all smiley faces, some are frowny faces, they've got different colors. And then we can say the proximate feature of interest, the one we are currently working on, our representative, is the big one we're dealing with. This is as a representative for the entire community down there. Sorry that the arrow got a bit lost. And that's also where the sampling comes in, because, okay, I've got my observation on this one. I know this is a placeholder for this whole crowd down here. How do I describe that relation? And that's where we've got the sampled feature concept from. So we say the smiley we're working on is our sample. This could be your soil sample. This is the real world object it's supposed to be a representative of. So that brings the first connection there. And now I'm going to take away the observation, and I'm going to show you a bit on the sampling. So okay, now I have to make sure, what am I doing? I'm not quite sure on this presentation. Okay, I've got a sampling act. On April 17th, I sampled, and again, we reuse that feature of interest concept. Now the sampling is looking at the population and saying, okay, I've got this big crowd of smiley faces. That is my feature of interest. The sample, here we've got the sample I pull out of it. And then I can say who pulled that out? Okay, in this case, it was me. That could be some device. That is some sieve you are using to pull out the coarser fractions from the finer fractions. You have a sampling procedure which describes how that was done. So in this case, it was random selection. I grabbed a smiley to get on with my talk. And you can also provide information on preparation steps. What did you do with that sample? So that's why I was saying that a bit of the stuff you were talking about, what all gets done before you perform the measurement, actually fits into the sampling we have. There is a bit more on this. I did the absolute minimal version for here because the main focus was, again, on the observations and measurements. But there is quite a bit more there. And where it's also really nicely done is in SOSA SSN. So that is the core of it. Let me see what else I have as slides. Okay, wait, this is irrelevant because that's Inspire. That's also irrelevant. That shows where all in the world it's used. One short disclaimer, because I know that everybody bitches, where is the unit of measurement? And if we go back to these slides, we don't have it. And okay, I wouldn't know what unit of measurement to put with a color. If I did this in frequency, maybe. We very purposely have not put it down because different systems, different communities do this differently. And some have it linked to their observed property or to their procedure. And sometimes they want it in the observation, and sometimes they want it in the result, because sometimes they actually want to have a time series where they change the unit of measurement, even if you tell them that this is very bad voodoo. So what I did get into the newest version, that was the last change we made, is I put in a requirement that you will provide a unit of measurement. It is not nailed down where you will provide it, but you will. So that is as a simpler way of explaining that. This slide, I'm going a bit fast because I really want to show you also the implementation we've done. And you did steal half of my hour and we're almost over anyway. Okay, here we have it in use. We've got the sensor observation service was the original OGC web service for this. It's a nightmare. If you want to see terrifying XML, click those links. They're operational. You have the air quality data in real time for Austria. Have fun. Then we've got a new and improved version. We've got a beautiful little API, the Sensor Things API. And this has become my special darling. So, I mean, it is incredibly powerful. You can do queries that blow your mind. And at the same time, it provides you JSON data, which you can use easily. You've got the same two data endpoints for the air quality are also available. We mirror them in a Sensor Things, just to shame the SOS. And anything more you want to know about Sensor Things is on the API for Inspire link there. And that's how we actually made this pretty thing, which I started out with. So that's all running on Sensor Things. And now very quickly to show you these soil things. What did we do there? Okay, does this help you? It helps you a bit because this is now the soil domain model we slipped in. Make that a bit bigger so that it is readable. And so the data stream is Sensor Things, thing is Sensor Things, location is Sensor Things. These three are Sensor Things native. And this is a new development, which I've done the last weeks with Hilke van de Schaaf, who is one of the main developers. Did I almost say that right, Penny? Thank you. And there, the thing we've been adding or been trying to think about is Sensor Things itself has a very small compact data model. Let me very quickly show you that also, because then you understand why this is different. Click, click. So Sensor Things has this data model. It is almost observations and measurements. It is subtly different. And the data stream is sort of an observation collection, which was introduced here. But you see all of the things I was talking about, the observed property and the sensor observer. The feature of interest is down off the observation. The thing is the host, but it's really nailed down to this model. No more, no less. And it then gets ugly because then you have different types of soil, plot, site, profile, horizon, and you are stuck with things. And we didn't like this. And so we had some interesting headbang and said, wait, what happens if we define all of the various soil spatial feature types which the domain people say they need and love? And make them all available, link them properly. This is sort of a simplification of the Inspire soil model. And link it to the location so we know where things are, and the data stream so we can add observations to these things. To keep it aligned with basic sensor things, we then take it's basically thing polymorphism. All of these things you can see as subtypes of the base thing, and to allow access by standardized clients who just know the thing concept. We have database tables for all of these in the background. We create a view where we fold them all together into one big table and say they're all things. And so the cool thing with this approach is you've got the generic thing approach with the rest of the sensor things model here. Any generic vanilla sensor things browser can work with it. And for anybody who looks into the details, you've got the specialized soil types with all the relevant information you want on your horizon versus your body. And that we actually have running in real time. This is the data set is a bit funky because it was harvested off of an Inspire prototype. But is there anything interesting I can show you? Exactly. So we've got, do we have the thing? We've got the thing. So if I go to things, we get a whole long list of various JSON objects, and one can maybe by their properties see what it is. So this seems to be a plot since it has a plot type, but here they're all folded together into something. This one seems to be something else because it has different properties. Yeah, it's horizon. So this way you just see them as generic things, figure out what it is. However, if you can also go down here and you can say, okay, I want to see just all profiles. And then you get a nice list of profiles. And the nice thing is that they are also then linked to various other soil types. Within the thing, they were just all things, so they couldn't link to other things. But somewhere in here, I can say, okay, I've got the plot. So I can say this profile comes from this plot over here. At the same time, I can say this profile, where do I have the horizons? I have all horizons and layers this is defined by. So I can directly link here and say, okay, I want to go and see this horizon. This is various information we've got on the horizon itself. And also just a quick final thing, since our time is almost up. So I can say I want to know what is measured on this horizon. I go to the data streams. I want to see what data streams do I have on this. So I've got a whole set of data streams on here. I can see what the observed property is. So I can see what they are measuring. I click on the observed property. I say, Fanny, what are they saying? It's Flemish.
Color description.
Okay, thank you. So I've got the color description, and then we have to go to the observation. And there we have the color description, dark brown. I can figure that out if I know the color description. So, I mean, what I did now was a bit complicated, clicking through object by object. The really cool thing is, I mean, if you're defining a system with it, you can define queries where you nest the various stuff in. So you can do one call, and that gives you all horizons with all color observations, and all of that is one object. Okay, I think that's my 30 minutes.
So this seems to cover a lot of what we want and need. I couldn't tell if you have things like soil fractions, particulates and things of that nature in there.
Those will be observed properties, I'm assuming. And I mean, there we would have to check what observable properties do they have, and then ask Fanny nicely to translate them, because it's, I really just dumped it.
So there are some soil fractions sort of present an interesting case here, because there's this concept that different soil fractions will complement each other and you can put it back to get a property of the whole. And you can take multiple observations on different fractions. So you can do sort of like, what's the nitrogen content of this fraction? What's the carbon content of this fraction? And so on and so forth. So I'm not saying this necessarily breaks the model, but it would.
But the fractions would fit under the sampling I was showing you.
Mhm.
So I mean, that is, if you pull out one smiley face, or if you say you sieve out this fraction, so that is a way of subsampling, and then you do your various observations on your fractions.
Okay.
And that's also what the proximate ultimate feature of interest helps you sort of keep track of, because your proximate feature of interest is the fraction. Your ultimate feature of interest is the entirety of fraction that out of.
Well, one of the reasons I asked the question is I could see that you had soil layers, and you can do your observations on a particular layer that Kathi was talking about. Analogously, you could do the same thing on a fraction.
Same thing.
I therefore wondered whether you should have a box for soil fractions the way you have box for soil layers.
If you want to do an observation on it, you would need a box
Yes.
in this domain model.
Yes, that's I guess that was my question, whether that should be added.
And I mean, this here, the first goal was to support the requirements from the European Inspire Directive.
Mhm.
That's what all European data providers need to get sorted. That's what Fanny and I were chewing through a month ago. And where we said, okay, how can we do this in a cool manner? And this is the result.
So the fractions are not used, I think, that much. It's quite specific. So you would do typically on a horizon or a layer or on an entire profile, you would do observations that then you describe through the whole model that was just that you just explained. So it was not the first necessity for us to look at fractions, because it's basic. Well, it's not a nice word maybe, but it's more of a niche.
Mhm.
And the first objective was to really be able to describe soil and normal soil sampling, soil description. So first get that sorted, get the structure, get the code list, make something that works. And we're really, really grateful for Kathi to actually, so this is very, very recent. So we met, I think a month ago, more or less, 1.5 months ago. We had a course in Wageningen in the Netherlands on Inspire and implementation, and all of this came along as well. And in the meantime, this happened. So yeah, it's just really nice to be able to describe soil, to have something that works. And then the next question is, okay, so what is needed to extend it? Or do we have cases where we need an extra box, or where we do not have all the code list yet? Or if you could describe some more procedures that are maybe not yet in the common list. So we first said, okay, let's first describe the common methods that everyone always needs, and then take it up to extensions and etc.
Very cool.
I agree. This is sort of like the 80-20 thing, where this particular 20% of work covers 80% of what you need.
I would say already 90, 95.
Okay, yeah. I don't quite
But okay.
understand the thing. I don't quite understand thing that DB view on between the data stream and location.
That's where the reason I flipped quickly over to the basic sensor things model. So I mean, the OGC sensor things API has this model standardized, and officially this is exactly what you get. This is what we had 6 weeks ago when Fanny and I talked, and the problem was that thing didn't quite cut it for all of the layer horizon plot bits, and that's why I came home. I talked to Hilke, we've been thinking in this direction for a while because we've been running into this issue of how to apply this to the various domain bits and pieces. So he'd gotten the software also already sort of set up for this type of abstraction. And then it was just a matter of slipping in the data model. And this thing down here is to maintain the consistency with the core standard. So these six specialized classes are
Okay.
all mirrored in here.
Yeah, it's like an intersect variable.
And I mean, it's basically, it's polymorphism. These are all subclasses of thing.
Or an inherited class from my old software development days.
Exactly.
All right, so we're at the top of the hour. So
One quick question on Codelists, because this also came up with the EGP work, and maybe you've got an answer. It actually turns out that a serious number of European data providers bypass the various FAO lists for horizons and the WRB stuff, and they use the USDA stuff.
Mhm.
Do you all have that somewhere referenceable online?
No, I don't believe so. I could put you in touch with some of the NRCS folks who work with the NCSS, but I do not believe that they have gotten terribly far in digitizing their reference resources yet. I think it's on their pending projects. I could be mistaken, however, so I should bite my words and put you in touch with folks who can give you definitive answers instead of my quasi speculations.
That would be really helpful if you could just anyone who within the US who is working on USDA taxonomy, but also USDA soil description, to come up with those code lists, and then we can discuss, okay, where are they put? Can we reference to them or whatever? I think that would really help a lot of folks, because then this starts to get live. Then you can actually use it. Then you can apply it, right?
So when you say Horizon code lists, are you referring to things like the methods descriptions and things along those lines?
That would also be nice. But for instance, the different texture classes within USDA field soil description, or the different classes for organic matter, or stoniness, or carbonate content, or how is it defined? So what is the definition of carbonate content? And then how it is measured in different lab methods.
Yeah, so some
that was
of
a whole shebang, basically.
Some of that is there, and I can show you it's embedded in as a table in the Access database for the NCSS, at least, so their main backbone database. But I should probably put you in touch with some proper folks there to
well, but so if you're talking about the KSSL lab database, I have a copy of that, so that could work. I think we were wondering if it's somewhere deposited online in like a code list format with also version and owner and all of that.
My suspicion is no, but let me put you in touch with folks to give you the definitive answer there.
Okay. I've been talking to some people at KSSL NRCS, but yeah, we didn't get this far yet. So if you have other entrances, that would be really nice.
All right.
A short thing to Gary's comment, I put in links for my presentation, and also the short document I put together describing everything with, I think it's got all of the links I showed. If anything is missing, please complain. And exactly what Gary put in is what we would like to have at a code list. I mean, I've done most of the work to now get these into the Inspire registry for the FAO WRB ones. So those will be available, referenceable online, that you can just put in a URL which is persistent and use that.
So I would love to take those code lists and take it a step further and start talking about sort of hierarchical relationships between methodologies. And that would be the most useful for my harmonization work in creating these data collections, is how do the code lists when and how do they talk to each other?
Yeah, sure, but then we need the basics first, right?
Yeah, no, I agree,
No.
which is to say that I would love to be involved in wrangling Codelists.
Okay.
So.
Okay, cool. Yeah, so on like Kathi said, on the FAO guidelines for soil description and on the WRB classification, the version 2007 at the moment, and we're working on the other ones hopefully soon as well. That we've been working on, and we're really encouraging European countries to make those code lists, deposit them also for their national systems. And the US system is also a national system that should be deposited somewhere. And we were kind of hoping that maybe that was already the case. So if you can enthuse people to work on that or put it somewhere that is with a nice URL, like a W3ID, for instance, or just that would be
better than W3ID because those have been running into issues with.
Well, okay, any proposal we can also provide a template
we can work
for
out
that.
The details.
No, but we can provide templates and all of that. But it would be really nice if the USDA system and taxonomy was also properly described in Codelists. But Kathi, correct me if I'm wrong. Eh? You always know better how to say it.
Well, I mean, the problem with the W3 IDs is ideal are IDs which resolve our URL and they resolve to exactly that concept. And with the W3 IDs, the problem is that you've got one file which contains 100 concepts and the URL resolves to the file go look. And you're then stuck with a pile of XML encoded RDF and have fun. So, I mean, I will find it, but most of your data providers will get lost. And that's why I've been going more for registry systems where each concept has a unique, persistent, stable URI. And if you put that into any browser, you come up with a web page which tells you what it's about. And ideally, if you do content negotiation, your sparkly system can get that in RDF and do cool, intelligent stuff with it. So, I mean, there's software out there for it. So that's what I think we really need. And then we can slowly iterate our way to something. One final note on the sensor things and semantics. One of our next steps for version 2 is utilizing JSON LD, because that allows you to sort of bridge the gap between something pragmatic in JSON, which the kiddies can develop something with, and the semantic information you need to pull it into a triple store. And there the idea is you basically provide in the header of your JSON payload, the mapping, where do your JSON attributes, how do these map to ontology concepts? And that's become sort of my golden compromise, because I mean, my dream would have been to have all of this running in OWL, but after 20 years, I'm giving up. And at the same time, just JSON doesn't cut it. And that is the end. My guests are ringing at the door. I wish you
All right.
bye.
Take care. Thank you so much.
Thank you.
Thanks, Kathi.